The most massive star we have ever found is destroying itself. Not because it is dying of old age, not because it ran out of fuel, because it grew too large. And the thing killing it is not gravity. The thing killing it is its own light. That star is called R136A1. It sits in a neighboring galaxy, roughly 300 times the mass of our Sun. And right now, at this very moment, it is shedding its own mass into space, violently, continuously, because the universe will not allow it to exist at its current size. Now here is the question that should stop you. Why? Why does the universe allow stars to form at almost every size? Tiny red dwarfs barely larger than a planet, medium stars like our Sun, giants hundreds of times more massive, and then draw a hard line right here. Why is there a ceiling? Why does the cosmos, which seems so willing to produce extremes in every other domain, refuse to allow stars beyond a specific mass? The answer is not what you think, and once you understand it, truly understand it, you will never look at the night sky the same way again. Most people imagine the universe as a place of unlimited scale. Space is vast, and within that vastness, anything can grow as large as it wants, given enough material and enough time. Stars in this picture are simply enormous balls of gas held together by gravity. More gas means bigger star. Simple logic. But this picture is wrong. Not slightly wrong, structurally wrong. And the proof is written in the light of every star you have ever seen. Here is what a star actually is. Not a furnace, not simply a light source. It is a war that has been ongoing since the moment the star was born, fought between two forces that want completely opposite things. Gravity wants to collapse the star inward, to crush every atom toward the center, to compress and compress and compress without stopping. On the other side, the pressure created by the star's own heat and radiation, pushing violently outward against every kilogram of infalling gas. A star exists only because these two forces have found an uneasy truce. The moment that truce breaks, the star either collapses inward into a neutron star or black hole, or it tears itself apart entirely. Notice how your intuition expects gravity to always dominate. That makes sense. Earth, we live inside gravity every moment. Heavy things fall, structures crumble, the ground holds us in place. Gravity feels like the final authority, but inside a star, you are dealing with pressures and temperatures so extreme that a second force enters the equation, one that behaves nothing like anything in your daily experience. That force is the pressure of light itself. This is the idea that stops most people. Photons have no mass, light weighs nothing, and yet light carries momentum. When a photon strikes any surface, even a single atom, it delivers a tiny push. In everyday life, this pressure is too weak to notice. But inside a massive star, trillions upon trillions of photons are produced every second, streaming outward from the nuclear furnace at the core. The combined pressure of that radiation is not tiny. In the most massive stars, it is the primary force holding the entire structure against gravitational collapse. Not the heat of the gas, the pressure of the light trying to escape. This is a simplified explanation to make the idea intuitive. The full picture involves the opacity of ionized plasma, the precise relationship between mass and luminosity, and the mechanics of how photon energy is transported from the core to the outer stellar layers. But the core logic is exact. Radiation pushes outward, gravity pulls inward, and the star survives only while those two forces hold their balance. Now here is the first question I want you to hold in your mind. If both forces grow stronger as you add mass to a star, gravity increases because there is more material to pull, and radiation increases because the hotter core produces even more photons. What happens when the radiation grows faster than the gravity can match? Pause and predict what happens next. You have a star, you keep adding mass, the core grows hotter, more photons are produced, more outward pressure builds. At some precise point, one side of the war begins to win decisively. Which side? And what does winning actually look like? Here is what actually happens, and it is one of the most precisely calculated phenomena in all of physics. There exists an exact threshold, a specific mass. Beyond it, the radiation pressure produced by a star becomes so overwhelming that it cannot be contained. The outward push of light exceeds the inward pull of gravity across the entire stellar surface. The outer layers are no longer held down. They are launched into space. The star begins to shed itself, not gently, not gradually, in eruptions that can expel multiple solar masses of material over just a few decades. The star is not dying of old age. It is destroyed by its own light. Astrophysicists call this threshold the Eddington luminosity, after Arthur Stanley Eddington, who derived it in the early 20th century. The number it produces, the maximum mass a star can sustain against its own radiation, sits between roughly 150 and 300 times the mass of our Sun, depending on the chemical composition of the stellar material. Within that range, the universe draws its line. Below it, stars can live for millions or billions of years. Above it, stable existence is simply not permitted. Here is the misconception this destroys completely. Most people assume the largest things in the universe are also the most powerful and stable. More mass means more gravity means more control. In stellar physics, the exact opposite becomes true at the extremes. The most massive stars are not the most stable. They are the most volatile objects in the known universe, teetering, violent, self-destructive structures that the cosmos is actively working to constrain. Consider Eta Carinae, a star 7,500 light-years from Earth. In the 1840s, it erupted so violently that it briefly became the second brightest star in the night sky, visible even in daylight. Sailors navigated by it. Astronomers watched in confusion, because it had not exploded. It had simply released more energy in a few years than our Sun produces in a million. It shed several solar masses of material into a glowing shell of gas that still surrounds it today, and Eta Carinae survived. It still burns, still sheds mass, still flickers at the very edge of the Eddington limit, a star the universe is actively cutting down to size. You have probably felt this without realizing why. The sense that some things in nature have a natural ceiling. Mountains can only grow so tall before gravity crumbles them. Waves can only reach a certain height before physics breaks them apart. These are not coincidences. These are the universe writing its laws into the physical world. Here is what makes this extraordinary. The GPS system in your phone works only because engineers correct for the effects of relativity. Time runs slightly faster for satellites in orbit than for receivers on the ground. Without that correction built into every calculation, your navigation would drift by kilometers each day. The same mathematical laws governing the ticking of a clock on a satellite 60 kilometers above Earth are the identical laws that set the maximum mass of a star. These are not separate rules for separate domains. They are one unified structure of constraint, operating at every scale simultaneously, without exception. Now here is your second interaction moment. If the Eddington limit defines the maximum mass a star can sustain, what happens when a gas cloud tries to form a star above that limit in the first place? Does the star exist even briefly? Pause and predict. The universe stops it before it can fully form. When a collapsing gas cloud accumulates enough material to approach the Eddington limit, the radiation from the newly igniting core becomes powerful enough to halt infalling material before it arrives. The star pushes back against its own birth. It refuses to grow past the limit because the light it produces at that mass becomes a wall that prevents additional mass from crossing. The universe does not just constrain existing stars, it prevents stars from forming too large in the first place. And when two already massive stars merge, a process that can happen in the dense cores of star clusters, the combined object can briefly exceed the safe threshold. What follows is called a pair instability supernova. At extreme temperatures, gamma rays produced in the core begin spontaneously converting their energy into pairs of electrons and positrons, matter and antimatter born from pure light. This drains the core of its radiation pressure almost instantaneously, in a fraction of a second. Gravity wins the war in milliseconds. The core collapses. The rebound tears the entire star apart in a blast more violent than a standard supernova, and it leaves behind nothing. No neutron star, no black hole, no remnant at all. Just an expanding shell of enriched gas and an absence where something vast once existed. The universe does not just limit stars. It completely erases the ones that transgress its laws. Now step back and hold the full picture. Every star in every galaxy across all 2 trillion observable galaxies operates under this same constraint, not because of local conditions, not because of the chemistry of any particular nebula, because the Eddington limit is derived from constants that are identical everywhere in the universe. The speed of light, the mass of a proton, the charge of an electron, the strength of gravity, these numbers do not change, and therefore the limit they produce does not change. The maximum size of a star is not a regional rule, it is a feature of reality itself. as fundamental as anything we have ever measured. Without this limit, the most massive stars would not explode the way they do. They would collapse into black holes, taking with them the elements forged in their cores, the carbon, oxygen, iron, and calcium produced over millions of years of nuclear burning. Without the Eddington limit forcing violent, dispersive deaths, none of that material would ever reach the interstellar medium. There would be no enriched gas clouds to seed the next generation of stars, no rocky planets, no oceans, no organic chemistry, no biology, no one ever looking upward at night and asking why stars have a maximum size. Every atom in your body, the iron carrying oxygen in your blood, the calcium holding your bones, the carbon linking your molecules into the shapes of life, passed through the core of a star that eventually grew too bright for gravity to hold and destroyed itself. You are not simply made of star material. You are made of material that was liberated by the universe's most precise and ruthless law. The limit did not prevent complexity. The limit is what created it. We began with R136A1, burning, shedding, tearing itself apart at the edge of what the universe permits. We asked why the universe cares how large a star becomes. Now you know. It cares because caring is what laws do. The maximum size of a star is not a coincidence, not an approximation, not a tendency that bends at large enough scales. It is the exact mass where light becomes too powerful for gravity to hold, and the universe enforces that boundary at every scale, in every galaxy, across every billion years of cosmic time. Reality is not a space of unlimited possibility dressed in mystery. It is a structure of enforced constraint dressed in fire. Reality is defined by limits, not illusions.